Your phone can find your exact location, anywhere on Earth. But here's the strange part. It does this using satellites that are 20,000 kilometers above you in space. So how do machines orbiting the planet know exactly where you are? Think about it for a moment. You could be standing in the middle of a city, driving on a highway, or hiking on a mountain far away from civilization. And within seconds, your phone can show a tiny blue dot that represents you. Not just the city you're in, not just the street, but sometimes your exact position within a few meters. No wires connecting you to space. No visible signals traveling through the air. Yet somehow, satellites thousands of kilometers away can pinpoint where you are on a spinning planet moving through space at incredible speed. It almost sounds impossible. So how does GPS actually know where you are? Here on Simple Things Why and How, we take everyday technologies we rely on and uncover the fascinating science quietly working behind them. And today, we're exploring one of the most incredible invisible systems humans have ever built. The Global Positioning System, or GPS. Right now, high above your head, there are dozens of satellites orbiting the Earth as part of the Global Positioning System. These satellites are constantly moving around the planet at about 14,000 kilometers per hour, completing an orbit roughly every 12 hours. Each satellite carries an incredibly precise atomic clock and continuously sends a simple radio signal down toward Earth. That signal contains two important pieces of information. First, the satellite's exact position in space, and second, the exact time the signal was sent. At first glance, that might not seem very useful. But together, those two pieces of information allow your phone to perform an extraordinary calculation. When your phone receives a signal from a GPS satellite, it compares the time the signal was sent with the time it was received. Radio signals travel at the speed of light, about 300,000 kilometers per second. So if the signal took a tiny fraction of a second to reach your phone, your device can calculate how far away the satellite must be. For example, if the signal took 1/10 of a second to arrive, your phone knows the satellite must be about 30,000 kilometers away. This gives your phone a rough distance between you and that satellite. But there's a problem. Knowing the distance from just one satellite doesn't tell you where you are. It only tells you that you must be somewhere on a huge invisible sphere surrounding that satellite. So GPS needs more satellites. To pinpoint your exact position, your device listens to signals from at least 4 different satellites. Each one provides another distance measurement. Where those distances intersect, your location appears. This process is called trilateration, a mathematical technique that determines a position based on distances from multiple known points. Imagine 3 spheres expanding through space from 3 satellites. Where those spheres overlap is your possible position. Add a 4th satellite, and the system can refine the calculation even further, correcting tiny timing errors and locking onto your exact location. Within seconds, your phone determines your latitude, your longitude, your altitude. In other words, your precise position on Earth, all from signals traveling across space. The reason GPS works so accurately comes down to time. The satellites use atomic clocks, some of the most precise clocks ever built. These clocks measure time so accurately that they would only lose about 1 second in millions of years. Why is that necessary? Because even a tiny timing error can create a huge location mistake. If the timing is off by just 1 microsecond, your position could be wrong by 300 meters. That's why the entire system relies on extremely precise synchronization between satellites and receivers. Interestingly, GPS satellites even have to account for Einstein's theory of relativity, because time actually moves slightly differently in space than it does on Earth. Without correcting for those effects, GPS locations would drift by kilometers every day. Although GPS feels like a simple phone feature, it is actually maintained by the United States Space Force, which operates the satellite network and ensures the system stays synchronized. And GPS isn't just used for navigation apps. It powers airplane navigation, shipping routes, emergency services, financial networks, and even the time synchronization used in global communication systems. In other words, modern civilization quietly depends on it. The next time you open a map and see that tiny blue dot showing your location, remember what's really happening behind the scenes. Signals are traveling from satellites 20,000 kilometers above Earth. Atomic clocks are measuring time with unbelievable precision. And your phone is solving complex geometry problems in fractions of a second. All just to answer one simple question. Where are you? It's one of the most incredible invisible systems humans have ever created. A network in space constantly helping billions of people find their way. If this changed the way you think about something as simple as a map on your phone, leave a like so more curious minds can discover it. Share it with someone who loves learning how everyday technology really works. And subscribe to Simple Things Why and How, because sometimes the tools we use every day are powered by the most extraordinary science. And sometimes, the smallest blue dot on your screen connects you to an entire network orbiting the planet.